Testing. Um, all right. Non-resident training course, September 1998. Navy Electricity Electronic Training Series Module 24. Introduction to Fiber Optics. NAVEDTRA 14196. Distribution statement approved for public release. Distribution is unlimited. All right. Chapter 1, background of fiber optics. Chapter 2, fiber optic concepts. Chapter 3, optical fibers and cables. Chapter 4, optical splices, connectors, and couplers. Chapter 5, fiber optic measurement techniques. 6, optical source and fiber optic transmitters. 7, optical detectors, fiber optic receivers. 8, fiber optic links. All right, throughout this text of the course, while you read the technical associated with the equipment you will be working on, you will find the loading notation and some of the paragraph notations are used to emphasize safety hazards and care must be taken observed. Warning, operating procedure practice, etc., which may result in injury or death is not carefully observed or followed. Caution, operating procedure practice condition which may result in damage not carefully observed or followed. Note, an operating procedure practice condition, etc., which is essential to emphasize. And Chapter 1, background on fiber optics. Learning objective. Learning objective is at the beginning of each of the chapter. The learning objectives are the preview information expected to learn in the chapter. Comprehensive check questions are based on objective by successfully including the NRTC. You indicate that you have met with the objectives of learning information. Learning objectives are listed below. Upon completion of the chapter, you should be able to do the following: describe the term fiber optic, list the part of the fiber optic data link, understand the function of each of the fiber optic data link part, outline the progress made in the history of the fiber optic technology, describe the trade-off of the fiber properties, component selection, design fiber optic systems, list the advantage and the disadvantage of fiber optic system compared to electrical communication, definition of fiber optics. In the other Navy electronic training series of modules you made, you learn the basic concept of electrical system. Electrical systems include telephone, radio, and cable television, radio, or cellular light links. In the past 30 years, research has developed a new technology that offers greater data rates over the longer distance of the cost lower than the copper wire system. New technology is fiber optics. Fiber optics are use light to send information more formally. Fiber optics is a branch of optical technology concerned with the transmission radiant power light enters through fibers. Fiber optic data links. Fiber optic data link sends input data through the fiber optic components provided with this data as an output information is the following of the three basic functions. Convert an electrical input signal to an optical signal to send optical signals over an optical fiber to convert the optical signal back to electrical signal. Fiber optic data link consists of the three parts: the transmitter, optical fiber, receiver. Figure 1 is an illustration of fiber optic data link connection. The transmitter, optical fiber, receiver perform the basic function of the fiber optic data link. Each part of the data link is responsible for the successful transfer of the data signal. With the fiber optic data link is needed to transmit that effectively convert an electrical input to the optical signal lines for the data connection light down for the optical fiber. Fiber optic data link is also needed for the receiver that can effectively transform the optical signal back into the original form. This means the electrical signal input provided the data output should exactly match the electrical signal provided as data input. Data input transmission connector, optical cable splice, and receiver and data output. The transmitter for the cover the input signal, the optical signal for the transmission. The transmitter consists of two parts: interface circuit with the server source drive circuit. The transmitter drive with the circuit converts the electrical signal and optical signal depth of the varying current flow through the light source of the two signal. The optical source of the lighting emitting diodes, laser diodes. The optical source launch for the optical signal linked to the fiber. The optical signal will become progressively weakened, distorted because of the scattering, absorption, dispersion mechanism in the fiber waveguide. Chapter 2 discusses the fiber mechanism, scattering, absorption, dispersion. Chapter 3 discusses the type of optical fibers and cables. The receiver converts optical signal except the feedback of the electrical signal. The receiver the part of the optical detector signal conditions. The optical detector detects the optical signal conditions or the condition of the detector output. So the receiver output matches the original input to the transmitter. The receiver should amplify process of the optical signal without increasing noise, signal distortion, noise in the disturbance that occurs with reduce the quality of the signal. The noise affects limitations signal conditions are going to cause the distortion of the receiver's electrical output signal. An optical detector can either be semiconductor positive and intrinsic negative diode or an leveling photodiode. The positive intrinsic negative diode changes the electrical conductivity according to the intensity of the wavelength of the light. The positive intrinsic negative diode consists of the intrinsic region between the positive and the negative type of semiconductor material. Chapter 6 provides the further explanation of optical sources. Chapter 7 provides further explanation of optical detector. Fiber optical data link also includes the passive components other than optical. Figure 1.1 does not show the optical connections used to complete the construction of fiber optic data link. Passive components used to make the fiber connections after the performance of the data link. These components can also prevent link the link from operating fiber optic components used to make the optical connections include optical splicers, connectors, and couplers. Chapter 4 outlines the typical optical slices, connectors, couplers, their connection properties, their system performance. Alright, performance integrated part of the design, fabrication, installation, anti-fiber optical system barriers measurement techniques are used to test individual data link. Each data link part of the test must be sure the link is operating properly. Chapter 5 discusses the laboratory and field measurements used to measure link performance. History of fiber optic technology. People have used light to transmit information hundreds of years ago. However, not until the 1960s, the invention of the laser widespread interest of the optical light system, data communication systems began. The invention of the laser provided the research for the study of the potential fiber optic for data communication sensing. Other application laser systems could send a much larger amount of the data of the telephone, microwave, other electrical systems. First experiment with the laser involved letting the laser beam transmit freely through the air. The research also conducted the experiment later letting the laser beam transmit through different types of waveguides with the glass fiber, gas filled the tubes, the focusing lens, example optical wave. The glass fibers soon became the preferred medium for the fiber optic research. Initially, the very large loss of the optical fibers prevent coaxial cables from being replaced. So the decrease in the amount of lighting the reach end of the fiber. Early fibers lost around 1,000 decibels a kilometer, making them impractical for communications. In 1969, several scientists conducted the impurity of the fiber material to cover the signal loss for the optical fiber. The basic fiber material did not prevent the light signal from reaching the end of the fiber. The researchers believe that it is possible to reduce the loss of the optical fibers by removing the impurities. By removing the impurities, the destruction of low loss opticals was possible. There are two different basic types of optical fibers, multimode fibers, and single-mode fibers. Chapter 2 discovered the difference between the fiber type. In 1970, the Corning Glass Works made a multimode fiber with losses under 20 decibels a kilometer. The same company in 1972 made the high silicon core multimode optical fiber 4 decibel kilometer minimum attention loss. Currently, multimode fiber can have losses of 0.5 decibels a kilometer with wavelengths of up to around 13 n meters. Single mode fibers are available to loss lower than quarter decibel at wavelengths around 15 nms. Development semiconductor technology provided the necessary light source for the further the development of fiber optic light source for the such lamp lasers were not easily used. The fiber optic system light source tended to be the larger required lenses systems to define lines of light with the into the fiber. In 1971, Bell Laboratories developed a small area of light emitting diode. This light source was suitable for the low loss coupling with the optical fiber. The research could then perform source of the fiber to join easily and repeatedly. Some of the early semiconductor sources had operating lifetimes only a few hours. However, the 1973 projected lifetime lasers advanced to a few hours greater than 1,000 hours. 1977, the projected lifetime lasers advanced to greater than 7,000 hours. In 1979, the device available to projected lifetimes more than 100,000 hours. In addition, researchers also continue to develop new fiber optic parts. The new type of the new ports developed include low loss fibers, fiber cables, slices, connectors. These parts permitted demonstration research for the complete fiber optic system. Advanced fiber optics have been permitted the introduction of fiber optics in the present application. The applications mostly telephone long haul systems growing to include cable television, computer network, video system data links. Research should increase system performance, provide solution to existing problems. Applications impressive. The result of the early research showed that there are many advantages offered over the fiber optic systems. Fiber optic systems design center of the long haul communication subscriber loop plant with a subscriber loop plant is part of the system that connects the subscriber to the nearest switching center. Cable television enable limited work. Also have been done short applications. Some of the military systems initially central office for the trunking required multimode optical fibers moderate good performance. Fiber performance dependent on the loss single distortion. Introduce the fiber that operating specific wavelength. Long haul system requires single mode optical fibers with very high performance. Single mode fiber tend to have lower loss and produce less single distortion. In contrast, short distance military systems tend to use the only multi-mode technology. Examples of short distance systems include the process control, local area networks, or land short distance multiple systems having communications, large fiber core, and higher fiber numerical aperture. Multi-mode fibers reduce loss of the connection. Chapter 4 claims the fiber connection property in more detail. Chapter 2 provides more detailed multi-mode single-mode fibers. In military subscriber applications, some of the design parts of the selections are related. Designers consider the trade-off of the following areas: fiber property, typical type of connection, optical source, and detector types. The design developer system with more meet stringent work requirements while training to maintain economic performance. Quite difficult to identify the standard system. The design approach of the module identify the type of the component chosen by the Navy for shipboard applications. Future system design improvements depending on the continued research except for the fiber optic product improvements to upper grade performance, lower cost, storage distance, application future system center of the board band services that will allow transmission voice video and service will include the television, video, word processing, electrical banking, and shopping. Advantages and disadvantages of the fiber optic. The fiber optic system has many attractive features for the superior electrical system. These include improved system performance, immunity, electrical noise security, improved safety, electrical isolation. Other advantages will include the reduced size and weight, and environmental protection of the overall system economy. Table 1.1 detail of the main advantage of the fiber optic system. System performance greatly increase the bandwidth capacity, lower signal attenuation, loss, immunity, electrical noise, immune to noise, no crosstalk, low bit error rates, signal system signal security, difficult to tap non-conductive, does not radiate signal, electrical isolation, non-conduct around, require freedom from the short circuit as far as size, weight, reduced size and weight cables, environmental protection, resistant radiation, corrosion, resistant to the temperature variation, improve the ruggedness of the flexibility, less restricted to harsh elements, and environments, overall system economy, low per channel cost, low insulation cost, silica is principal, but inexpensive material sources, and despite many advantages of the fiber optic system, there are some of the disadvantages of the relatively new technology fiber optic components are expensive for the fiber optic transmitter, but still relatively expensive compared with electrical interfaces. Lack of standardization is near the industry, limited with the acceptance of the fiber optic. More industries are more comfortable with the use of electrical system, reluctance to switch to fiber optics. However, the industry researchers eliminate these disadvantages. Communities addressing the fiber optic part, test standardization, cover the install of the fiber optic system failing, because of the increase of the use of the fiber optic technology, publish articles, conference letters, lectures on fiber optics have become the educated manager technicians as the technical nature of the use of the fiber optics will increase because of the many advantages over the electrical system. Chapter 1 Summary.